Okay, 2.8, we're going to introduce the product rule. Okay, the product rule is useful for finding the derivative when you're multiplying two expressions. You know the derivative for each of them, but you just don't know the derivative of them together. Okay, so the derivative of f times g, and it's times, which is why it's the product rule, equals f times g prime plus g times f prime. So it's the first function times the derivative of the second plus the second function and then times it with the derivative of the first. Okay, let's look at the example so you can see when might you use it. Okay, so for A, they're telling me f of x equals 8x sine x. Okay, now I don't know the derivative of 8x sine x altogether. So I want to split it into two things being multiplied together. So I see the 8x in the front. I know the derivative of 8x. I see the sine x over here, and I know the derivative of sine x. So I'm going to use the product rule, where this is the first function, and this is the second function. Okay, I could divide it up differently, and I'll get the same answer, but whichever way you see as obvious is the way you want to do it. Okay, so to find the derivative, okay, I'm going to do the first function times the derivative of the second. So the first function is 8x. The derivative of the second function, the derivative of sine x, is cosine x. Plus. Okay, now I'm going to do the second function times the derivative of the first function. So the second function is sine x times the derivative of the first function, the derivative of 8x is 8. Okay, and that's how the product rule works. I'm going to rewrite this answer just so it looks a little bit cleaner. Okay, I don't mind. I'm okay with the 8x cosine x. It's not bad. But for this second term, if you're doing sine x times 8, the 8's a coefficient. I'm going to move it to the front because otherwise you can't tell if you're doing the sine of x times 8 or if you're doing 8 times the sine x. So in this case, we're doing 8 times the sine x. So I'm going to move the coefficient to the front. Okay, but I am going to leave it like this because this is a good expression. Okay, let's go ahead and look at B. Okay, B, you want to split it up into a product because altogether I can't rewrite this as one single expression, but I can make it look like two things. Okay, I'm going to keep the 2e to the x in the front. I'm going to rewrite the square root of x as x to the 1/2. Okay, and then I'm going to keep this as my first function, and this is my second function. You could do it different, like you could put the 2 on the second one and not on the first one, but it's not going to make a difference as long as I know the derivative of both. Okay, so if I want the derivative of g of x or g prime of x, I'm going to do the first function times the derivative of the second function. So that's going to be 1/2 x to the negative 1/2 plus I'm doing the second function times the derivative of the first function. The derivative of e to the x is e to the x, so I'm going to keep it 2e to the x. Okay, this looks a little ugly. Let me make it a little bit better. Let's see, the 1/2 and the 2 cancel anyways. So let me keep the e to the x in the numerator. The x to the 1/2 is going to go to the bottom. And the next to the 1/2 is just the square root of x. So let's rewrite it like that. Okay, and then what else do we have? We have the 2e to the x. And I'm going to put x to the 1/2 as square root of x. I'm going to put it second. And the reason I put the radical second is just so that the 2e to the x doesn't get confused about whether it's in the radical or after the radical. So I'm just going to put the radical last. And that's commonly what people do. But I am going to leave it like this. Okay, let's do one more equation, then we'll look at a table. Okay, so C is going to be this expression here. It's a product. I can see the first thing times the second thing. I'm going to make this my first thing. Okay, I'm going to make this my second thing. I think I'm going to rewrite that 1 over x, though. I don't like that. So first thing, second thing, let's use product rules. So h prime of x is going to be the first thing times the derivative of the second thing. Bring down the 2, that's going to be 4x, just 4x. Okay, plus the second thing times the derivative of the first thing. So I'm going to bring down the negative 1, so that's negative 1, x to the negative 2 plus 0. I'm going to make it look a little nicer. Actually, I'm going to put the fraction back. 1 over x plus 1, because I think it's going to be easier to distribute. Hold on, my squared has gone astray. There we go. Okay, if I do 1 over x times 4x, the x's cancel, I get 4 plus 1 times 4x is 4x. And then I'm going to distribute negative x squared times negative 1 over x squared times 2x squared is going to be negative 2. Negative 5 times negative 1 over x squared is going to be positive 5 over x squared. Let me condense the 4 and the 2. So that's going to be 4x plus 2 plus 5 over x squared. And I'm going to leave my answer like that. Okay, now if you're pondering to yourself, like, what if I had just distributed this? Couldn't I just have distributed this and then done the power rule to it? You totally could have. I could have just done distribution on the first step, and then I would have used the power rule, and then I should have gotten the same result. So there are times when you'll have a choice about which procedure to do, and then you can choose accordingly. Okay, let's go ahead and look at this table, and use the table and the product rule together. There we go. Okay, here's the table. These are the x's. X is 2, x is negative 5. This is saying what f of x is. So this is f of 2 is 4. F of negative 5 is 3. This is telling me what f prime of 2 is negative 2. G of 2 is negative 1. G prime of 2 is 2. Something like that. Okay, how are we going to use this? Okay, they're going to tell me h of x equals 3 f of x times g of x. Find h prime of 2. Okay, because this is already composed two functions, I'm going to do this one as my first, this as my second, and I'm going to use the product rule. Okay, now the product rule. I'm going to do the first thing times the derivative of the second thing plus the second thing times the derivative of the first thing. Fair? Okay, now they want me to evaluate h prime of 2. Okay, so I'm going to go ahead and get the values from the table. Am I going to rewrite this? I'll rewrite it. So this is 3 times f of 2 times g prime of 2 plus g of 2 times 3 times f prime of 2. Okay, where's the table? Okay, f of 2. F of 2 is 4. So 3 times 4 times g prime of 2. G prime is here, 2 is here. So g prime of 2 is 2 plus g of 2. Here's the g column. X is 2. So g of 2 is negative 1 times 3 times f prime of 2. F prime is here. F prime of 2 is negative 2. Okay, and then I'm going to evaluate it. 24 plus 6. So h prime of 2 is 30. And I use the product rule and the table to figure that out. Okay, let's go ahead and try the last one. Okay, this time they're telling me r of x equals this big product thing. They want me to find r prime of negative 5. Okay, I'm just going to rewrite Rx like a teeny bit. F of x over 2 is really 1/2 f of x. And you don't have to rewrite it, but just remember that, because some people get confused when they do it. Okay, let's go ahead and use product rule. Let me make this my first function, and I'm going to make this my second function. Okay, r prime of x equals the first function times the derivative of the second function. Okay, the derivative of 3 is 0 minus g prime of x. Okay, plus the second function times the derivative of the first function. So the derivative of 1/2 f of x is 1/2 f prime x, and the derivative of 2 is nothing. Okay, let's go ahead and evaluate this at negative 5. Okay, so 1/2, where'd my table go? I need f of negative 5. F of negative 5 is 3. And then plus 2 times negative g prime of negative 5. So g prime of negative 5 is 5 plus 3 minus g of negative 5. G of negative 5 is negative 2. Oh, so 3 plus 2 times 1/2 of f prime of 5. F prime of negative 5 is 4. Okay, I have all the values I need. Now I just have to evaluate this. So what do I have? I have 3/2 plus 2 times negative 5 plus 5 times half of 4 is 2. So this is 10 plus, okay, 3/2 plus 2. 3/2 plus 4/2 is 7/2 times negative 5, which is negative 35 over 2 plus 10, which is negative 35 over 2 plus 20 over 2. So r prime of negative 5 is negative 15 over 2. Okay, so that's my final answer.